You're listening to the N2K Space Network.
The DMV has established itself as a top-tier player in the global cyber industry. DMV Rising is the premier event for cyber leaders and innovators to engage in meaningful discussions and celebrate the innovation happening in and around the Washington, D.C. area. Join us on Thursday, September 18th to connect with the leading minds shaping our field and experience firsthand why the Washington, D.C. region is the beating heart of cyber innovation. Visit dmvrising.com to secure your spot. Risk and compliance shouldn't slow your business down. Hyperproof helps you automate controls, integrate real-time risk workflows, and build a centralized system of trust so your teams can focus on growth, not spreadsheets. From faster audits to stronger stakeholder confidence, Hyperproof gives you the business advantage of smarter compliance. Visit www.hyperproof.io to see how leading teams are transforming their GRC programs.
Today is August 25th, 2025. I'm Maria Varmazes, and this is T-Minus.
T-Minus. 20 seconds to LOS. T-Dress. Go for deploy. Roger, roll.
China sets a new world record by heating a tungsten alloy to over 3,100 degrees Celsius, and that is the highest heating temperature achieved in space material science experiments.
4.
SpaceX scrubbed the 10th Starship test flight ahead of takeoff due to an issue with ground systems.
3.
NASA's SpaceX 33rd commercial resupply mission docked with the International Space Station.
2.
Rocket Lab celebrated the 70th Electron mission this weekend.
1.
And Rocket Lab to boost investments in the United States to expand semiconductor manufacturing capacity and provide supply chain security for space-grade solar cells and electro-optical sensors for national security space missions. And my former boss and friend of the show, Brandon Karpf, is joining me later in the show for our monthly Cyber and Space segment. He's going to try to convince you and me that 3 seemingly unrelated news articles having to do with the space industry from the last 10 days will represent a massive shift of wealth from Singapore to Greenland in the next 10 years. Intrigued? You should be. Stick around for that really fun chat after today's headlines. Happy Monday, everybody. Let's dive into today's Intel briefing. Rocket Lab has announced their plans to boost investments in the United States to expand semiconductor manufacturing capacity and provide supply chain security for space-grade solar cells and electro-optical sensors for national security space missions. The Trump administration will support these investments with a $23.9 million award through the Department of Commerce, part of the CHIPS and Science Act that ensures U.S. leadership in space-grade semiconductor technology. Rocket Lab's capital investments over the next 5 years are expected to strengthen the company's market position as a leading satellite manufacturer, components supplier, and end-to-end mission provider for commercial and national security space missions. Rocket Lab is one of only 2 companies in the United States that specialize in the production of high-efficiency, radiation-hardened, space-grade compound semiconductors. And through these investments, Rocket Lab expects to nearly double production capacity of compound semiconductors and space-grade solar cells from 20,000 wafers to nearly 35,000 wafers per month. And speaking of Rocket Lab, our next story is about them too. They celebrated the 70th Electron mission this weekend. Their amazingly named Live, Laugh, Launch mission lifted off from New Zealand on August 23rd, less than 3 weeks after Electron's previous successful launch from the same site. The mission for an undisclosed customer was the 12th flight of 2025 for Rocket Lab. And the majority of Electron missions launched this year, including the Live, Laugh, Launch mission, have been the continuation of multi-launch contracts with satellite operators to deploy their constellation in low Earth orbit. SpaceX launched the 33rd commercial resupply mission to the ISS over the weekend. The company's Dragon capsule docked with the International Space Station earlier today. The spacecraft carried more than 5,000 pounds of supplies, including new scientific experiments and cargo for NASA's resupply mission to the orbiting lab. It docked autonomously at approximately 7:30 a.m. Eastern Time to the forward port of the space station's Harmony module. In addition to carrying cargo to the station, Dragon will also perform a reboost demonstration to maintain the ISS's current altitude. And the hardware that's located in the trunk of Dragon contains an independent propellant system that's separate from the spacecraft to fuel 2 Draco engines using existing hardware and propellant system design. The boost kit will help sustain the orbiting lab's altitude starting in September with a series of burns that are planned periodically throughout the fall of 2025. That said, it wasn't a completely successful weekend for SpaceX. Their 10th Starship test flight was scrubbed on Sunday evening. SpaceX says the reasoning for the canceled test launch was to allow time to troubleshoot an issue with their ground systems. And they say that they could try again as early as this evening from 6:30 p.m. local. And SpaceX wasn't the only space company to encounter issues this weekend. Blue Origin also scrubbed their planned New Shepard launch. Jeff Bezos' company shared on social media that, quote, the team encountered an issue related to the booster's avionics. And the Blue Origin NS-35 was due to carry payloads to the Kármán line from West Texas. No details, though, have been shared about when that flight will be rescheduled. And let's head on over to China now for our last story. As they have been breaking records on Tiangong Space Station, taikonauts on China's orbiting lab have set a new world record by heating a tungsten alloy to over 3,100 degrees Celsius, which is the highest heating temperature achieved in space material science experiments. 3,100 degrees Celsius is nearly half the temperature of the sun's surface, by the way, so yeah, a little hot. The record was set through a collaboration between the in-orbit crew and a ground-based research team led by the School of Physical Science and Technology at the Northwestern Polytechnical University. The research findings hope to offer an important theoretical basis for the design and performance improvement of new tungsten alloys, and will play a significant role in fundamental research on the application of ultra-high temperature materials in the nuclear industry and aerospace field. Congratulations to them on their amazing achievement. And that wraps up today's headlines for you. N2K senior producer Alice Carruth joins us now with a look at the other stories that we are keeping an eye on today. Alice, what do you got?
If you're on the East Coast and close to the Mid-Atlantic regional spaceport known as Mars, then you're in for a treat tonight. The TOMX Plus mission is finally going to lift off today with the launch window opening at 10:30 p.m. local time. We'll hopefully bring you more on that launch on tomorrow's show.
Thanks, Alice. I'm going to keep my eyes to the skies in hopes that I catch that one too. And a reminder that you can read more about that story and all the others that I've mentioned throughout today's episode by following the links in the selected reading section of our show notes, which are also available on our website, space.n2k.com. Hi, T-Minus crew. If you would like daily updates from us directly in your LinkedIn feed, be sure to follow the official N2K T-Minus page over on LinkedIn. And if you're more interested in the lighter side of what we do here, we are at T-Daily on Instagram. And that's where we post videos and pictures from events, excursions, and sometimes some behind-the-scenes treats. Links are in the show notes for you. Hope you will join us there.
You hear from us here at T-Minus every single day. Now we'd love to hear from you. Your voice helps shape the future of N2K networks. Tell us what matters most to you by completing our annual audience survey. Your insights help us grow to better meet your needs. There's a link to the survey in our show notes. We're collecting your comments through August 31st. Thanks.
Mint is still $15 a month for premium wireless. And if you haven't made the switch yet, here are 15 reasons why you should. 1, it's $15 a month. 2, seriously, it's $15 a month. 3, no big contrast. 4, I use it. 5, my mom uses it. Are you playing me off? That's what's happening, right? Okay, give it a try at mintmobile.com/switch.
Upfront payment of $45 for 3-month plan, $15 per month equivalent required. New customer offer first 3 months only. Then full price plan options available. Taxes and fees extra. See mintmobile.com.
Today's guest is Brandon Karpf, friend of the show, my former boss, founder of T-Minus Space Daily, and cybersecurity expert. Brandon decided to do a Stump the Host play for this month's space and cybersecurity segment.
I'm going to try to convince you and all of your listeners that these 3 seemingly unrelated articles having to do with the space industry from the last 10 days will represent a massive shift of wealth from Singapore to Greenland in the next 10 years.
Okay. Listeners, I just want you to know that is also all I know. I know nothing behind the scenes here. So what articles are we talking about, Brandon? Let's start there.
All right, cool. So I'll start with the headlines from these articles. Okay. Voyager Technologies makes investment into AI software company, Latent AI. KSAT, which is Kongsberg Satellite Services, plans to take its ground network to space with hypersatellites in LEO. Illyria reports milestones with tight beam laser communications.
Okay, so Voyager Tech investment in Latent AI, KSAT plans ground network with hypersatellites in LEO, and Illyria's milestones with tight beam laser comms. Okay. I'm stumped. Aside from these are all headlines I know that we have covered on T-Minus Space Daily. I have absolutely no idea what else would be the common thread here. So regale me, Brandon, because I'm very
what is the common thread between these 3 things, which are seemingly unrelated and all from the last 10 days?
Yes.
And my argument is that these developments, which are really just representative of a number of developments over the last few years, represents meaningful steps towards moving core internet backbone traffic from terrestrial fiber lines to space-based architectures.
Introduce me to where and how Singapore and Greenland come into play here on that thesis.
We'll get there. Let's start with the technology developments themselves. In my mind, right, this idea of shifting core internet backbone traffic from terrestrial fiber lines to space-based architectures really requires developments in 3 core technology areas, right? The first being orbital data centers, right? Data centers in space, being able to process data in situ in low Earth orbit.
Yep.
Second is actually moving meaningful software technologies, and that's going to come with investments in edge AI, because edge AI is really just driving increased compute power. With that increased compute power investment, which we're trying to send to low Earth orbit, which we've seen with this Voyager Technologies investment, is going to have to come developments in mostly like heat transfer technologies and power generation technologies. Because both those systems, the GPUs, the CPUs, generate tremendous amounts of heat and require tremendous amounts of power. And so Voyager's investments in these types of companies, and there's a number of others as well, will drive rapid changes and investment in creation of heat transfer technologies and power generation technologies in space. Now, the third area that is required to move meaningful amounts of internet traffic from terrestrial systems to space systems is high-speed optical laser communications. That is the most critical enabling technology.
Okay. I'm starting to see this thread appear. And I'm just thinking, okay, I can think of recent missions for a lot of these. Like there's a mission going to ISS just recently about orbital data centers, which I was really amped about. So,
and I'm glad you brought up the ISS testbed as well, because that's a partnership between Axiom Space and Red Hat being the massive Linux Foundation organization. And I didn't choose that one because that was originally announced a few months ago, and I wanted to pick things that were just announced in the last 10 days.
Yeah.
But you're right, that is going up like this week or something like that.
As of the time of this recording.
And that test case is orbital data centers being tested. It's a partnership between Axiom and Red Hat and being tested on the ISS. And so that's already going to introduce new power generation systems, heat transfer systems, et cetera, for processing data in situ in space.
All right, so we're talking about we have in place in movement the required technologies for the core internet backbone traffic to go from terrestrial to space-based. I'm working backwards. Obviously, that will represent a whole bunch of interesting cybersecurity challenges, I would imagine, but I'm sure you'll get to that at some point.
Most definitely.
So can I ask about the Singapore-Greenland thing yet, or are we still not there yet? 'Cause
We're still not there yet. We're going to get there. Oftentimes when folks talk about moving core backbone internet traffic from terrestrial fiber lines to space, people bring up the issue of throughput, right? We just can't push enough data to make it worthwhile to shift transmissions from the core undersea fiber lines, and that's
massive lines.
Undersea fiber lines. We're talking about terabits per second, terabits and terabits per second over those massive fiber lines to a space-based architecture. However, developments in processing in space, as well as laser communications, which Illyria is investing in, is getting us actually quite close to terabit per second transmissions. And just this year, a group out of China successfully demonstrated 400 gigabits per second. And Illyria has plans and designs of getting up to 1 terabyte of data per second across a single optical link.
Right.
And so Illyria's recent milestones, just from the other week, demonstrated that they're making meaningful steps. And just in the last 6-7 years, we've had a 1,000x increase in the amount of data we can push over optical links. Right? That type of acceleration is going to get us to meaningful terabits per second across optical links within the next few years. That is going to represent enough throughput to start shifting internet traffic from terrestrial fiber cables to space-based architectures.
And then also edge AI coming into play here, where especially for space-based applications where you don't have to necessarily use all that throughput because a lot of the processing is done on edge. That's not going to necessarily be relevant for all applications, certainly, but when we're talking about things that are requiring tons and tons of compute, if you can do it in space instead of being like shipping the data back and forth over and over, that's a big efficiency, right?
Exactly. Big efficiencies gained,
okay.
More flexibility, right? You're no longer requiring to send data through these terrestrial systems. You're no longer worried about the fiber lines getting cut by anchor chains of illicit fishing vessels. It's also more flexible in terms of failover and shifting aggregate capacity onto different links. And more importantly, on top of all of that, when you think about these constellations of thousands of satellites, you'll have access to more than one optical link. You could have access to numerous terabit optical links at a single time if you have ready access to a meaningful ground station for that type of communication.
Okay. You know what question I want to ask now? Are we there yet? Okay.
I think we're close enough. I think we're there. Singapore is just an illustrative example of areas of centralized communications around the world. There are many of these. Djibouti is one of them. Egypt is another. The U.S. West Coast, even Brazil has some centralized areas where it was convenient to drive all of the fiber lines to one centralized processing region. These actually typically mirrored traditional maritime shipping lanes. Basically, what is the fastest way to get from point A to point B across the ocean? Well, that's where we also ended up laying fiber lines.
Yeah.
We don't need those maritime shipping lanes anymore for space-based architectures. And so where can you get the most efficient communications from space to ground? Where is the least amount of interference? Where is the least expensive real estate for ground stations for these optical links in these proliferated low Earth satellite architectures? More polar regions, not the equatorial regions. And so I think that what we're going to see as these technologies develop and as you see Kongsberg investing in these optical ground stations and actually deploying ground station type services in space as well, is an increase in investment in physical real estate in the polar region. So anyone with Arctic or Antarctic access, so that could be Chile, that could be Norway. I used Greenland because I thought it was funny to compare Greenland to Singapore. As investment shifts, you're going to see more and more technology companies, communications companies, et cetera, starting to invest in those regions as they can start getting core internet access through polar-based ground stations.
So fascinating geopolitical implications of this, certainly, that I know we've been seeing in the news in the last year.
Most certainly. And a lot of folks maybe were laughing at the Trump administration for their potentially interest in taking over Greenland. But there actually might be some strategic reasons for Western nations to build closer relationships with those regions of the world.
Yeah, that kind of is starting to make a little sense now. We've barely touched on the cybersecurity implications of all this, which I'm sure could take another hour if we wanted to get into that.
Certainly.
If you can do it in like 3 minutes, if that's even possible, what are we looking at for maybe a thesis on what this could mean for cybersecurity implications?
Yeah, there are a few. And first, I'll just talk about infrastructure, right?
Yep.
When you have a ground station, you don't want to transmit data over a long distance. So those regions will probably also see an increased investment in data centers and terrestrial systems like that, in internet service providers and telecom providers being in those regions as that architecture continues to grow. That'll, of course, shift investment out of the traditional regions of centralization for those things, such as Singapore. That'll create some economic stress, of course, not necessarily directly related to cybersecurity. However, it is relevant.
Yep.
But what I will say, though, is that the use of optical transmissions introduces a number of great security features. It is a tight beam type of communication, so it is much more difficult to snoop and spoof a laser-based communication. So in terms of the transport architecture itself, there's more security just by the nature of using an optical link. Optical links can process faster, so more heavy forms of encryption and cryptography can be used, so that can increase the security posture as well. There's also ways of multiplexing signals across an optical link that could make your signal much more difficult to detect and intercept as well. However, I would also say, though, some of these regions that we're talking about, the Norways of the world, the Greenlands of the world, et cetera, are going to need, if my thesis comes to pass in the next 10 years, are going to need more investment in security of their digital ecosystem. You don't typically hear about those nations when it comes to cybersecurity, when it comes to having folks on the ground and security services and security forces in those regions actually defending that infrastructure, that critical infrastructure. And so it would be great to see those nations ahead of time starting to work with the U.S., with the UK, et cetera, on critical infrastructure protection and how we can secure the physical assets for the digital ecosystem.
Oh, so blue teamers, there's a bunch of job openings coming in some countries that you may not have expected in the future.
Right.
So I really enjoyed this version of Stump the Host. You took me on a journey, and I appreciate that very much. Honestly, it's a really fascinating idea. I think you are onto something legitimately. So thanks for this really great idea. I appreciate it.
Yeah, it was absolutely my pleasure, Maria.
We'll be right back.
This episode is brought to you by Indeed. When your computer breaks, you don't wait for it to magically start working again. You fix the problem. So why wait to hire the people your company desperately needs? Use Indeed's sponsored jobs to hire top talent fast. And even better, you only pay for results. There's no need to wait. Speed up your hiring with a $75 sponsored job credit at Indeed.com/podcast. Terms and conditions apply.
Welcome back. Late breaking news now, folks. I know this one isn't the most earth-shattering revelation, but for some of us, it's darn important. Listen close now. NASA says we officially have our top 25 finalists in the running for the Artemis II official zero-G indicator, people. Run, do not walk to nasa.gov and check out the August 22nd blog post titled NASA shares final contenders for Artemis II moon mascot design contest, and scroll a tiny bit down to where you can see those finalists sent in from creative folks all over the world, and just enjoy, honestly, because, oh my goodness, they are so stinking cute. And NASA had to pour through over 2,600 entries from over 50 nations to get to this top 25 list. It's a tough job, but someone's got to do it, right? And remember, whoever wins this contest will be on the Artemis II mission, going to space, going around the moon, keeping the crew company, giving them their first heads up that they truly aren't at 1G anymore. It's quite an honor for a Stuffy. As for the top 25, for a moon mission, unsurprisingly, several entries were either rabbit-related or Luna Moth-related. And there is one adorable goddess Artemis facsimile, complete with her bow and arrows, of course, they're all soft. And I guess I shouldn't be surprised that one entry from Maryland is crab-related, with a lunar crustacean. Unknown if it will smell like Old Bay. And no matter who the final winner is, I think I will still need my own Rise mascot sent in by Lucas Ye of Mountain View, California, because it is a mascot version of the iconic Earthrise photo. It is a super clever design. I know. How in the heck would that work? Oh, my friends, it just does. Go check it out. And all of the entries and pick your winner. The final decision, though, appropriately, belongs solely to the Artemis II crew. So, NASA astronauts Reed Wiseman, Victor Glover, and Christina Cook, and Canadian Space Agency astronaut Jeremy Hansen, they get to pick out the winner. So, I cannot wait to see what they choose. And that is T-Minus, brought to you by N2K Cyberwire. We would love to know what you think of our podcast. Your feedback ensures we deliver the insights that keep you a step ahead in the rapidly changing space industry. If you like the show, please share a rating and review in your podcast app. Please also fill out the survey in the show notes or send an email to space@n2k.com. We're proud that N2K Cyberwire is part of the daily routine of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K helps space and cybersecurity professionals grow, learn, and stay informed. As the nexus for discovery and connection, we bring you the people, the technology, and the ideas shaping the future of secure innovation. Learn how at n2k.com. N2K senior producer is Alice Carruth. Our producer is Liz Stokes. We are mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Peter Kilpie is our publisher, and I am your host, Maria Varmazes. Thanks for listening. We'll see you tomorrow.
T-minus